Hello everyone, I am Rahul Christus from Networking and Cloud. This session is about a serverless solution to export app and infra metrics from Citrix ADC to monitoring services. Before we do a deep dive into the session, let's try to answer a few questions regarding metrics. First of all, are metrics critical? If metrics are critical, how do I extract these metrics? And what do I do after I extract these metrics? We all know that metrics are very critical for any deployment as they provide critical data points about any component in the infrastructure. They provide critical information about the deployed application, about its health, and if the application is misbehaving, it can also provide essential data to debug it further. Apart from the application point of view, metrics can also provide essential data regarding the infrastructure and the security aspects of the deployment. These metrics can be easily extracted from the Citrix ADC using Nitro API. Citrix ADC would load balance the application, so it would have all the data regarding the application that it's load balancing. Moreover, Citrix ADC has a robust list of metrics that can provide essential data about the application and infrastructure as well. Now, these extracted metrics can be exported to any monitoring service like CloudWatch, Datadog, Google Operations, so on and so forth. So the goal of this session is to see how easy it is to pull metrics from Citrix ADC and export them to monitoring services like AWS, CloudWatch, and Datadog. Let's have an overview about the components used in this session. We would see some basics on the Citrix Nitro API and about AWS services and Datadog. Citrix Nitro API. Nitro is a REST-based API which is very simple and efficient. Since it's REST-based, it's programming language independent. All the metrics from the Citrix ADC can be extracted using a simple curl command. The metrics extracted from the ADC includes metrics about the ADC itself, metrics about the application that it's load balancing, and other critical metrics like infrastructure and security aspects of the deployment. Some of the security metrics would be the SSL counters, the certificate related counters, and other details with respect to the security. Citrix Nitro API. Nitro is a REST-based API which is very simple and efficient. Since it's REST-based, it's programming language independent. So all the metrics from the Citrix ADC can be extracted using a simple curl command. The metrics that are extracted from the ADC include metrics about the ADC itself, about the application that it's load balancing, and also metrics with respect to the infrastructure and the security aspects. So apart from monitoring, Nitro APIs can also be used to configure the Citrix ADC itself. Compute. For compute, we use a serverless solution where we have a Python script running in AWS Lambda function. Since it's serverless, it's very cost efficient and it also eliminates the need to have a dedicated compute. And this Lambda function is triggered on specific intervals. So we have a schedulable triggered configured which can be modified based on the user needs. So apart from these schedulable triggers, we also have external triggers if the user needs. So once the Lambda function extracts the metrics from Citrix ADC, these metrics are then modified into a data that is acceptable to AWS CloudWatch and Datadog and then pushed accordingly to these monitoring services. So this is the overview of the components that we will be using in this session. Now, how do I extract metrics from Citrix ADC? Like I mentioned earlier, Extracting a metric from Citrix ADC is as simple as sending a curl command. So in my example here, I want to extract the system CPU metric from my ADC, for which I'm sending a HTTP request to the Nitro endpoint called system CPU. And to authenticate with my ADC, I'm using one of the simpler methods where I send the Nitro username and password in my HTTP headers, and also I'm mentioning the content type to be JSON. The response that I get from this curl command would give me the value of the system CPU metrics that I'm expecting. Likewise, the curl command can be used to get any of the metrics that is present in the ADC. To see a list of all the available metrics in the ADC, you can send a HTTP request to the Nitro root path, and that would give you a list of all the stacked objects, after which you can extract specific metrics under each of the stat objects. This is the demo setup. As you can see, the complete setup is in AWS Cloud, and the backend applications that I would be using in this demo is an EKS Kubernetes cluster running in AWS, which has a couple of Kubernetes nodes, and there are also a few Kubernetes pods running in each of the nodes. And I also have an autoscaling group which has a couple of Citrix ADC VPXs, and these VPXs would be front-ending my Kubernetes pods. In short, the VPX would load balance the microservices that are running inside my Kubernetes cluster. So this is just a sample deployment. The backend applications can be anything. It can also be a VM-based application or microservices like I'm showing here. The idea is to illustrate that this solution works across any deployment models. And about pulling metrics from the ADC, we use a Lambda function, and that's a Python script configured in the Lambda, which at regular intervals pull metrics from the ADC and then export them to AWS CloudWatch and Datadog. So this is about the setup. So this is the workflow of the script that is running in the AWS Lambda function. I'll start with the input arguments to the script. For input arguments, we use the Lambda environment variables. There are two parameters here, out of which one is mandatory argument. The mandatory argument is the AWS autoscaling group, where the VPXs are hosted. And we also have one more argument called Datadog API key, and this is an optional parameter. If the user wants to export the metrics to Datadog also, he can provide the key here, and we would export the metrics to Datadog. And there is also one more input to the Lambda function. It's the metrics template. So this is actually a template that would have information on all the Nitro metrics and Nitro endpoints that would be fed into the Nitro API client. So this would serve as a template that the Nitro API client would use to figure out the Nitro endpoints and the metric and data. Now I'll walk you through the script flow, starting from the input parsing. So the inputs that are provided in the AWS Lambda environment variables are first parsed by a module. Let's call it Citrix ADC details retriever. So this validates the inputs for the correctness, and then it queries the AWS autoscaling group to get all the available VPX instances and gets all the data of the VPXs. So to do this, we use the Boto3 Python library, and so basically in the entire operations and the script we use Boto3 for any communications with AWS APIs. And once we get the details about the VPXs, these information are then passed to the Nitro API client. So Nitro API client is nothing but a simple HTTP request sender. In this case, we just use URL lib Python library, and the metrics template is also fed as an input to the Nitro API client, so it knows what Nitro API to fire in order to get a metric value from the ADC. So after Nitro API sends all the Nitro requests to the ADC, it gets the Nitro output, and then it sends all those output to the Nitro parser module. Then the Nitro parser module does some error handlings and then sends the data to CloudWatch module and also to Datadog module. So let's talk about the flow for CloudWatch. Both CloudWatch and Datadog has two different data structures. So CloudWatch expects the data to be sent in a different structure, whereas Datadog has a different structure that it expects. So there is module that converts the Nitro data that we got from ADC. Then we convert that data into the data format which CloudWatch expects, and that is what this converter module does. And then we use Boto3 to push the metrics to CloudWatch. And when we come to Datadog's workflow, we again have one more converter module where we convert the Nitro stats that we received from ADC to a Datadog friendly structure, and then we use Datadog's API to push the metrics to Datadog. So this is in brief the workflow of the AWS Lambda function that we will be seeing in a while. Like I mentioned, this is a Python script that would pull metrics from ADC and push it to any cloud monitoring services. So the import section is very minimal. We are just importing the basic libraries required for this function to run. Like I mentioned in the workflow, we are using Boto3 Python library to interact with AWS APIs, and we are also using Datadog's API to send metrics to Datadog. So this is the metric template which I was mentioning would be bundled inside the AWS Lambda itself. To give an overview of how the metrics template would look, the metrics template is also a Python structured file. So there would be a variable called metrics, and that is actually a dictionary which would say what feature of the ADC and what are the metrics that to be pulled from the ADC. For example, let's take a simple metric. Let's go to the system metrics of ADC. The system metrics is the system level metrics of the Citrix ADC itself. There are many metrics in it. So let's choose num CPUs, which would give the number of CPUs that are available on the Citrix ADC. So we'll just say it as a metric name, and we'll just give a short description to it, and we'll say the type it is count and the unit it is unit. So the type and the units are required by the AWS CloudWatch and the Datadog. So we expect a template or a metrics template in this format from the user, so that the Lambda function that we are writing would be able to pass the metrics in a structure that CloudWatch and Datadog are requiring. So likewise, user can specify any number of metrics here, and the function would automatically fire nitros accordingly and retrieve all the metrics that the user has provided. Okay, now let's go back to the Lambda function. So these are the logging parameters. We are just using the general Python logger that is available. And here we are initializing the Boto3 clients. So we spawn a client for EC2 where we query all the AWS VPX instances, and we have a client for CloudWatch, and we have a client for auto scaling also. So AWS CloudWatch has a namespace parameter. So for all the custom metrics that is pushed from the user, it requires a namespace to be specified So in this example, I'm specifying a namespace as Citrix ADC. So likewise, Datadog has a prefix. Um, so for example, num CPU is the metric name. Um, how do we identify the num CPUs from different sources also, right? So what we do is that we would export the metrics as Citrix ADC dot num CPUs. So this is how it would look in the Datadog dashboard. So this is actually kind of identifier that identifies Citrix ADC metrics amongst other third-party metrics also. And that's a special tag here called include features. So this is one more step of filtering for the Nitro commands. So like I already showed in the ADC metrics, there are many features included here. For example, system is a feature, SSL is a feature, and service is a feature. So we provide one more level of filtering, whereas your metrics template can have 10 or 15 or n number of features included, and you can always have a flag here to specify that I need only 5 features out of the available 20 features or something like that. So this is optional. If you have an empty list, then we pull metrics using Nitro for all the available metrics in the metrics template. Else, when you have a specific features enabled, then we pull metrics only for these features. Okay, so this is a sample CloudWatch structure that I was talking about in my previous slides. So CloudWatch would expect the data to be pushed in this specific format. So metric name is where we will fill our metric name. So this will be the Citrix ADC metric name that we pulled using Nitro, and the value of the metric. For example, let's take an example of num CPUs that we saw previously. So in this case, metric name would be num CPUs and the value would be 1. The timestamp, we will just use datetime library in Python. And like I was mentioning in the metrics template, the unit is used here. So we'll just extract a unit from the Citrix ADC metrics template and then use that here. And dimensions are a special tag for AWS CloudWatch where we can do one more level of filtering when we analyze the metrics in the CloudWatch dashboard. So dimensions can be added as the user wishes, but here by default we add a description tag. We also append the autoscale group to it, and we also add the instance ID from where this particular matrix is received. So this kind of makes it unique for every metric. For example, there are 5 VPXs in autoscaling group. How do we figure out the num CPU is for which VPX, right? So this dimensions kind of makes the metric very unique. So this is how AWS CloudWatch requires the metrics to be pushed. And Datadog actually uses a different kind of format. So most of them look similar. Instead of metric name, it's metric here, and description is a separate tag instead of using the dimensions. And type. So type is similar to the unit. So even when I was explaining the metrics template, there was another field called type. So we just take that field and put it here. So points is where we specify the metric value, and host we actually specify the AWS instance ID here, and we also have special tags where we specify the auto scale group from where the metrics was received. And source, we just use AWS so that Datadog, it will be easier in Datadog when user filters based on source. Now let's go to the main. So in AWS Lambda, the main is actually the Lambda handler. So So this is the format of the Lambda handler. So this function executes first, and all the function calls should go from here. To go over the important aspects here, we have special flags that enables pushing to Datadog or pushing to CloudWatch. Like I was explaining in the workflow, pushing to Datadog was an optional parameter. Only if the API key is specified we push, else we just stick with CloudWatch alone. So this part is where we parse for the AutoSQL group name from the environment variable. And like I told, AutoSQL group name is a mandatory field, and if that is not specified, then we would exit and come out. And if API key is specified, we would enable Datadog feature here, and we would also initialize Datadog APIs here. And this is the place where we import the metrics template. Like I already mentioned, metrics template is also a Python file that has have a variable declaration, so it can be easily imported into this Lambda function. And in this section we iterate to the existing features in the metrics template and then compare it with the included features tag, where I mentioned that we have a second level of filtering. So we do some comparison here and figure out what Nitro API is to be fired for the entire script flow. So this function gets the list of all the VPX instances from the autoscaling group. Along with the VPX instances, it also gets few details like the instance ID, the NSIP, and the public IP of the VPX if available. So basically what all information the script needs, this function would get it done for us. And then we'll iterate to every VPX instance that we received using the retriever component, and we would fire nitro commands for each of the VPX instance, and the stats variable would have all the nitros for every VPX instance. And then based on the decision that was taken earlier, we push to CloudWatch, and if needed we push to Datadog. So this is in short the overview of the script that is running in the Lambda function. So I'll just show a function that I called it as a Nitro API client in the workflow. So let's go to that. Okay. So get feature stats is my Nitro API client. So here there are certain assumptions here. So just for my demo purpose, I'm just using my method as HTTP, but I always prefer to use HTTPS. And you can specify the username and password here. For now I'm going with all defaults here. And if your VPX has a public IP, and if you prefer to use public IP, then this variable will be filled automatically, and we would try to pull Nitro stats using a public IP. Else we'll fall back to the private IP of the VPX. And like I mentioned, we just using the URL lib Python library. So this is equivalent to the curl command that I was showing in my previous example. This is very identical, like the header sections can be seen. I just use the same three headers, the content type, the Nitro username, and Nitro password. So this is more or less the same curl command that I'm replicating here. So then some basic error handling here. Then we parse the data and send back to the caller. So this is my Nitro API client here. And now we'll jump to a section where this Nitro stats is getting converted to CloudWatch data structure and Datadog data structure. Okay, so this parse stats CloudWatch function takes care of converting the data to CloudWatch. So the input parameters of the VPX info and the actual metrics that are got from metrics template, and the actual nitro values for each of the metrics that is got from the ADC itself. So with this template, I've already given an overview in the introduction. So basically, we iterate to each and every metrics in the metrics template, and then simultaneously we search through the statistics or the stats dictionary, which is actually the metrics got from the ADC, and then we fill the values from the Nitro into the metrics, and then we change the format according to CloudWatch and then push it back to CloudWatch. So this function doesn't push the data to CloudWatch, so it just returns a data structure that is suitable to be pushed into the CloudWatch, right? So similar operations happens for Datadog too. We have a parsing function called parse underscore stats underscore Datadog, where the inputs are same, which is the VPX info and the metrics template and the metrics value received from the ADC itself. And we just do similar operation where we iterate through these Nitro values and fill the metric values in the metrics template, and then convert the data to Datadog dictionary, and then return it back to the caller. So the push part is very simple. So to push metrics to CloudWatch, we just have this function. In AWS CloudWatch, there's a limitation where in a single API post request, we cannot send more than 20 metrics list or array. So I'm just having a simple check here where if my length of my metrics list is more than 20, then I'm creating a chunk list with a length of 20, and then sending multiple Nitro calls to push data to CloudWatch. So like this. And to post data to Datadog, it's similar. There were no limitations. So again, it's just a one-line command where we just pass the dictionary here, and we use Datadog's API library to push the data, and that completes the script flow. So regarding the cost aspects, it would vary depending on how many metrics are you trying to pull from ADC, and how many data sources are you planning to export it to, and it also depends on how many VPX instances that are there in your autoscaling group. Let's get back to the slides. So these are few custom dashboards that I've created on AWS CloudWatch using the metrics that is pulled from the ADC. So these are pretty basic dashboards where I just have a dashboard where I'm showing some HTTP errors. In my case, there are some server BC errors. So the first chart is about that, and the second dashboard is also the HTTP incomplete request. So there were a few errors there. And to monitor the ADC system level parameters like CPU usage or memory usage, I have a couple of widgets there. So I'm plotting the CPU usage from a couple of VPX instances, and those are the next two widgets. By the way, my autoscaling group only has two VPX instances. That's the reason there are two widgets for the CPU usage, for instance 1 and instance 2. And the last widget is showing the vServer hits. There are two fields, 140K and 246K. So those are the hits in two different Citrix ADC VPXs. So I also created similar dashboard in Datadog as well. So where where the first column is showing the CPU usage. So this is pretty much the management dashboard, which I call it, where I can see the CPU usage and the memory usage and the disk usage. Similar dashboard can also be created for a traffic, where I can see the error counters, the total hits, or the load balancing vServer hits rate, or any other errors that the user desires. So in summary, we saw how much critical metrics were for any deployment. We also saw the different types of metrics that can be extracted from the ADC, and we also saw how easy it was to extract metrics using Nitro APIs. And the entire package can be formed into a script that can run in a Lambda function, which would extract metrics from one or multiple ADCs in a specific intervals, which is fine-tuned by the user. And lastly, these metrics can also be exported to any of your popular monitoring services for further analysis and debugging. We can also create nice dashboards based on the monitoring services where these data are exposed. Thank you, everyone. I hope this session was helpful.